Okay. Normally, if I was there, I would actually be having you divide up into groups to solve these or certain ones, and we'd come back together. So I'm going to work through as many as I can. If you're getting it, feel free to move on to the practice. I will tell you there's a couple of more difficult ones. But remember, the goal is to get the radical by itself first. So in this first one, it already is. So that means I'm going to square both sides. Okay, so I get x squared plus 2x plus 1 equals 7x plus 15. All right, I'm going to get it all to one side. So I'm going to subtract the 7x and the 15. So I get x squared plus, oh, that would be a minus 5x. Minus 5x and then minus 14 equals 0. And we factor. So what multiplies to negative 14 adds up to 5. I'm going to say a negative 7 and a positive 2. If we set each of those equal to 0, we get x is a positive 7 and x is a negative 2. So here is where you either want to graph this side, the x plus 1, and graph this and see where they intersect, or plug it in and check. So if I check this, we'll start with x equals 7. I get 7 plus 1 equals square root of 49 plus 15, because 7 times 7 is 49. So I get 8 equals the square root of 64. Hey, that's true. So I know that works. Now let's check x equals negative 2. So I get negative 2 plus 1 equals the square root of negative 14 plus 15. So I have a negative 1 equals the square root of a positive 1. That's not true, okay? So x equals 7 is truly the correct answer, even though algebraically I was able to get another answer. So remember, we've had problems like this in the past, but this is my extraneous solutions, or extraneous solution, where I have a solution that in the solving process, you can actually come up with that solution, but it doesn't actually satisfy the equation. When you plug it in, it does not work, okay? Now again, you could just graph each side. Where do they intersect? The x value is your answer. Now in number 2, I need a radical by itself. So I have to move one of them to the other side. So I'm going to move the one that is after the minus sign. I'm going to add it, so that way I don't have to deal with the negatives. So I'm going to add that square root of x plus 8 to the other side. So I have square root of 4x minus 4 equals the square root of x plus 8. Okay, square both sides. So you have 4x minus 4 equals x plus 8. I would move your x's to one side. So I'm going to subtract x, so I get 3x. And I'm going to move this 4 over there by adding 4. So I get, whoops, don't know what I was writing there, equals 12. To get x by itself, you must move the 3. It's 3 times x, so the inverse of that is dividing. So I divide by 3 and I get x is 4. So we check it, make sure it works. Square root of 4 times 4 is 16, so I have 16 minus 4 minus the square root of 4 plus 8, and that's 12. Okay, so 16 minus 4 is 12, so square root of 12 minus square root of 12 is 0. That works. There is my answer. Okay, I'm just going to plow through and keep doing this all in one video. I probably should at this point make 2, but I'm going to keep going. So pause it anytime you need things to slow down so you can like copy the screen or see if your group mates have questions, that kind of thing, or answers. So answers to your questions. All right. So this case, this one is not a radical, but here's x. So I need to get that by itself before I try to get rid of the power and solve for x. So you always remember order of operations. We are going to add or subtract first. So in this case, I have a minus 7, so I add it to both sides. I end up with x cubed over 5. If I add 7, I get 25. Okay, it's x cubed divided by 5. So now to get rid of the 5, I have to multiply by 5. So I get x cubed equals 125. Now we can get rid of the power. Well, remember, a root, if it's a third root, or a third power, it has a third root is its inverse, okay? So I'm taking the third root of both sides. So I get x equals 5. Okay? If you plug it in, 5 cubed is 125, divided by 5 is 25, minus 7 is 18. So this does work. All right, so that was just kind of showing you inverse. So if you have a power, you do the root to get rid of it. Now all these other ones, we have the root. We're going to take it to the power to get rid of it. So in this one, this is my root right here. That's what I need to get by itself. So I need to add or subtract first. So I'm going to move the 9 over. It's a positive 9, so I'm going to subtract it. So I get 5 times the third root of 2x. Subtract the 9, you get 20. Now it's 5 times my radical, so I need to divide by the 5. So I have the third root of 2x, divide by 5. 20 divided by 5 is 4. And now I have the radical by itself. So it's a third root, means I take it to the third power. So 2x now equals 4 to the third power, which is 64. Still need that x by itself. It's 2 times x. Opposite of multiplication is division. So I divide by 2. I get 32. So again, always check, plug it in to the original, make sure it works. This one, I'm just telling you right now, it does. So we can move on to the next problem. I'm trying to make sure you have some time to work on your practice in class. All right, now let's scroll up. Okay, actually, I'm going to stop this video here because one of these just takes a little bit longer. So we're going to stop the video here and then play the other video.